when we see formation of differential equation, we check a particular equation. If there is a constant in the equation, we try to eliminate the constant. So for this, we have a question here: form a differential equation from A, y is equal to a cos x plus b sin x. B, y is equal to c x minus c all squared. C, we have y squared is equal to a, 1 here, 1 here. That's the constant are 2, which is a and what b. Meaning you have to differentiate this function 2 times. Then I'll have, or the first differentiation will be, or before we differentiate this function, I'll try to make either a cos x the subject or b sin x the subject. So I'll make a cos x the subject. Then I'll get something like a cos x is equal to y minus b sin of x. Meaning I have to send b sin x to this side, leaving a cos x. So I'll have a cos x is equal to y minus b sin x. I will name this one star. So we will differentiate the equation 1. When I differentiate y, I'll get what? Dy dx is equal to a is constant, so I will differentiate cos x. I'll get minus a sin x. I will differentiate this one, I'll get plus b cos x. Name this one equation 2. Again, because we have 2 constants here, definitely have to differentiate it again. So I will differentiate this one. But before I differentiate this one, we know the y dx is the same as what? Y prime. So we have y prime to be equal to a sin x plus b cos what? X. So I will differentiate this one again. Then I'll get y prime prime is equal to, when I differentiate this one, negative a sin x. I'll get what? Negative a cos x. When I differentiate plus b cos x, I'll get minus b sin what? X. I will name this one equation 3. Now let's check this one. I can see that I have a cos x here. But when we go to star, a cos x is the same as what? Y minus b sin x. So in place of a cos x, I will choose to write it as what? Y minus b sin x. So I'll have my y. So here I will just write, put star into what? 3. Let me now, I want to factor star into equation 3. So I'll have my y prime prime. I'll have my y prime prime is equal to negative. There's negative here, a cos x, which is what? Y minus b sin x. So I'll have something like y minus b sin what? X minus b sin x. Multiply 2 by negative. I'll have minus y plus b sin what? X minus b sin x. Y prime prime. This take this one. So you have y prime prime is equal to negative what? Y. Send this one to this side. We have y prime prime plus y is equal to 0. So we're able to form the differential equation from this question. So that the final answer, there's no constant in this particular final answer. So we are able to eliminate all the what? Arbitrary constant from the question. Now let's solve the second one. I have b. Y is equal to c x minus c all squared. First, let's try to identify the number of constants in this particular problem. You see that we have the constants. We have what? Get c. This c is the same as the c here. So that we have only one constant. Then we have to differentiate this function just once. Therefore, when I differentiate this one, I'll have, or even before I differentiate, I'll call this one, this original equation 1. Then I will differentiate equation 1 with respect to x. So I'll have, when I differentiate this one, I'll get 1 multiplied, because it's a dependent variable, I'll get something like dy dx. But before, because you know like dy dx is the same as y prime, permit me to write this one as well, my y prime is equal to, now you have to differentiate the derivative of this one, power problem. Differentiate with power, multiply by when you differentiate with the other power. So when I want to differentiate this one with power, this is acting as a constant. So this power 2 will come and multiply the derivative. So then I will differentiate the function within the power that differentiate without the power. So differentiating the derivative of this one, I'll get 2c x minus c. 2 minus 1 is what? 1. Multiply when I differentiate without the power, there's only one x. When I differentiate this one, I get what? 1. So I get this one back. I will name this one equation 2. I have equation 1 here, equation 2 here. How to eliminate the c from this one? I can see that when I divide this equation by this equation, then I'll get something in terms of c. So what I will do here is that I will divide equation 1 by equation 2. So I'll have y is equal to c x minus c all squared divided by y prime is equal to 2c x minus c. When I'm dividing the whole equation 1 by equation 2, that's equation 1 by equation 2. This is x minus c all squared. X minus c, this is taking the power of 4. So when I differentiate this one, or when I divide this one by this, I'll get my y over y prime is equal to this c, will take the c here. I'll have half here, multiplied by x minus c. Cross multiply these two. I'll have 2y over y prime is equal to x minus c. Can we try to make the c the target here? I mean, I have to send, or I have to send this one to here, and move this one. So I'll have c to be equal to x minus 2y all about y prime. Name this one star. Now we'll put star into equation 1. Meaning we'll go to equation 1, that's the original question. Whenever we see c, we'll place it by x minus 2y all over x over y prime. So here putting c into equation 1, I'll have y here is equal to c, which is what? X minus 2y all over y prime. Multiplied by x minus, open the bracket c. So I have x minus 2y all about y prime. All squared. So now let's play this one. So I'll have my y is equal to x minus 2y all over y prime. X, now I want to multiply 2 by this negative. So I have negative x plus 2y all over y prime. All squared. Basically, taking this one, we'll have y is equal to x minus 2y y prime 2y about y prime all squared. This square, let's multiply by this one. So we'll have something like, or before you do this one, you know that this y is over 1. Find the LCM, try to rewrite. So I'll have something like x, as in this x, multiplied by this y prime minus 2y all about y prime. Multiplied by 2 power 2 is what? 4. This today is what? Y squared. This today is what? Y prime all squared. I have y is equal to this one. So I have y is equal to y prime multiplied by y prime squared is the same as y prime all cube. Then I'll have something like 4x y prime 4 y squared x y prime minus 2y whatever it is. I just move this 4y squared to this side in order to multiply everything, because the 4y squared is multiply everything. Cross multiply, then I have my y prime all cube is equal to 4y squared multiplied by y x y prime minus 2y. That's
we have this equation. We have y squared is equal to a multiplied by b plus x multiplied by b minus x. So here, let's try to calculate the constant. This was the constant. Now, a is our right hand. We have this one. Now, so the constant number 2. We have to differentiate this function twice. So let's go for the first differentiation. But before we differentiate this one, how to differentiate this side will be a problem. The tricky is that first we will try to do this thing. So I have y squared is equal to a b plus x b minus x, which is bracket will be b Or else to maybe when we want to differentiate this one, it will affect you, you not get it. So here, I'll just multiply through by this thing. So I have my y squared as in the y squared is equal to ab squared minus ax squared. So these are my numbers. So I'll name this one question 1. So we have to write our given question in terms of this. So first, let's differentiate. What we have to do from differentiate from the first differentiation. Y is a variable, y is a function of x. So when I differentiate, so I'll get 2y dy dx is equal to 1 to differentiate with respect to x. There is no x here, so now this side is 0. Minus this is acting as a constant. So when I want to differentiate this one with respect to x, I will differentiate this one become minus 2a to x. Now let me rewrite this one. Then I'll have something like 2y prime, y is the same as y prime, is equal to minus 2a to x. I have to be happy with the 2 rules. I have y prime is equal to minus a to x. Let me name a the constant, a negative a the constant, because I'll get y over x.
Y prime is equal to minus a. So I have y over x, y prime is equal to negative a. So the thing here is that I want to differentiate because we have two constants here. So we are done with the first differentiation. So we have to differentiate this one again. But watch here. What I will do here is that I will treat this as a product rule because this y over x is different. It's multiplying y prime. This and this are the same. So here, how to differentiate this one? First, product rule. I will differentiate y over x. Then I will keep y prime plus I will keep y over x. Multiply when I differentiate my y prime. So I'll get y prime prime is equal to, we want to differentiate everything with respect to it. There's no x here, so this side will be 0. Now let's differentiate. I want to differentiate the derivative with respect to x. Y over x quotient to v du dx minus u dv dx. So my v is what? X. When I differentiate this one, I'll get, when I differentiate my u, I'll get 1. But because our y is the dependent variable, I'll multiply this one by what? The y dx. Or likewise, the same as what? Y prime. Minus u, my u is what? Y. dv dx, you have to differentiate this and get what? 1. All over v squared, that's x squared. So the derivative of this one is multiplied by what? My y prime here. So plus y over x dot y prime prime is equal to 0. Now let's rewrite this one. So I'll have x y prime minus y all over x squared dot y prime plus y over x y prime prime is equal to 0. Now I'll multiply through by this y prime. So I'll have x indices, when the bases are the same, do what we add this, so I'll have my y prime all squared minus y prime all over x squared plus y over x y prime prime is equal to 0. I don't want to keep any fraction here, so what I will do here is that I will multiply both sides by what? X squared. Multiply both sides by x squared, and then I will get something like x y prime all squared minus y prime plus x y prime prime is equal to 0. So we are able to eliminate any constant from this side. You can see that x and y, they are not the constant. So the constant here, or the constant in this particular problem was a and what b, and at the final answer we are able to eliminate our constant from the given problem. So this is a differential equation because that contains differentiation. This y prime is the same as dy dx, the square y of what? The x squared. In summary, the castle formation of differential equation by elimination of arbitrary constant, meaning the number of question or the number of equation, the number of constants, the number of constants per any approach here waiting the year few. There are questions go ahead, we have to do substitution method. But we have to equation we have to do all the manipulation in order to get your answer. So anytime you can form a differential equation by formation of arbitrary constant, the number of constants, if you have two constants, you have to differentiate your function 2 times. If you have one constant, you have to differentiate your function just one. If you have infinity constant, you have to differentiate your function infinity times. Alright, so thank you.